I think this is the 2018 practice exam. I don't remember. Yep, 2018. Okay. It says people enter a line for an escalator at a rate. So automatically I'm thinking this is the derivative modeled by this function. This is the derivative because it's the rate. It is, I mean, that's what it says. Okay, it's a little piecewise function. That's great. Where RT is measured in people per second and T in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 per second. So this is them entering, this is them exiting. There are 20 people in line at time t equals 0. Okay, this is going to be important for when we need to take the integral. These are things that I'm just thinking out loud. Okay. So this is them coming in, this is them leaving. These are both rates. These are both technically a part of the derivative, just positive, negative, and this is the original. At t equals 0, 20 is our answer. Okay. How many people enter the line for the escalator during the time interval 0 to 300? Okay, it's just talking about enter the line. It doesn't say anything about exiting. You're good. Come on in. So, I'm helping in calculus. So, you just need the integral from 0 to 300 of this guy. You don't need to use 0.7 because it doesn't talk about people exiting. It just talks about people entering. So it should just be the integral from 0 to 300 of this fellow. Calculator, boom, done. During the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time 300? Okay, so we know how many people entered the line, but we need to know how many people exited the line. So literally, you take 0.7, take the integral of that, which is just 0.7t times 300 minus 0. That would technically be the integral. And then you subtract that from the other one. C, for t greater than 300, what is the first time t that there are no people in line for the escalator? So they stop entering after 300 seconds. That's what it says right here. So the question is, at what point does there become 0 people in line? Well, if we know how many people from B are actually in line at time 300, now all we need is just to figure out how long it takes them to finish that line, which again, they leave at 0.7 seconds, 0.7 people per second. So whatever that number is, whatever B's number is, they just have to leave at 0.7 per second, and that'll give us how many seconds, and that'll give us, we add 300 to that, and that'll tell us, at what time they were actually done. And then lastly, 0 to 300, for t0, in between 0 and 300, at what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time. Justify your answer. Okay, so we need to find when this is a critical, like when this guy equals 0, I believe is what we need to figure out. Because I'm trying to find a minimum, which again, it's talking about the derivative, right? Because when the derivative is, when that tangent slope is 0, then our function is a minimum or a maximum. And so we just need to find out when that is. So if we can do the Pauli root finder on our calculator, we'll find 2 answers, hopefully. And then you plug those into the original, and you get whatever time that is. Boom. Should be good. But we can check it, because I have this pulled up. Okay. All right. Got it. Got it. Beautiful. I don't know if I said add 20, but hopefully. Okay, so we had 80 seconds left, or 80 people in line. They leave at that rate. So it's just that many seconds. Boom, done. And then this one, yep, just needed to find when this minus this equals 0. Okay, perfect. Yep, beautiful. Okay, so it's R of t. We had to include the 0.7. I don't think I included the 0.7. So R of t minus that has to be equal to 0. You find two numbers right here, and then we just plug those in using our calculator. We're going to probably use the integrand, right? Integral 0 to 33. Figure out how many people are in line. 0 to 166. How many people are in line? That's the minimum. Okay, there it is.